Good evening. In our last video, we have seen BFS and DFS, breadth first search and then depth first search. So how you can able to traverse, how you can able to visit each and every node, we have seen very clearly in our last session. Now, in today's session, we need to talk about, sir, few more applications which are depending on this BFS and DFS. What is the first application is, sir, determine determining a path from vertex, okay, a path from vertex u to vertex v. Okay, so we have to implement a program to check is there any path is there from vertex u to vertex v. Okay, so here for the given source and destination. Okay, so we have to determine if a path is existed from source to destination or not. We have to check, sir. That's all. Beyond that, nothing. A simple application. It is nothing but one of the utility of these BFS and TFS. Sir, I will take two graphs for you to understand. The first graph. Okay, I will take only one graph. Okay. So like this, we have a graph and the connections between the graph vertices are nothing but we have like this. And coming to the names, so this vertex name is nothing but 0, and this vertex name is nothing but 1, and this vertex name is nothing but 2, and this vertex name is nothing but 3, and this vertex name is nothing but 4, and this vertex name is nothing but 5. Like this we have. Now my question is, sir, we have to check, is there any path? Okay, so is there any path? I will create a function called has path. I will pass this graph and 0 comma 4. So is there any path from 0 to 4? We have to check. Sir, definitely there is a path from 0 to 4, right? Not a direct path, maybe indirect also. So to reach from 0 to 4, is there any way or not? That's what I am asking. Yes, it is there. It has to return true. And is there any path from 0 to 5? We don't have, right? Because 5 is also a vertex, but there is no edge connected to this. In such cases, we have to get false. Okay, sir, what about these graph entries? What about these graph entries? There is an edge between 0 to 1, right? And there is an edge between 0 to 2. Next, and after that, there is a edge between 1 to 3. So next 1 to 0 is already completed, 1 to 3, and then 1 to 4. Coming to 2, is there any 2 to 0 is there? Already it is there. So 2 to 3 is there. That's all. So next and after that, what about 3? So we have an edge from 3 to 1. 3 to 1 is already there. 3 to 2, it is also already there. Sir, 3 to 4, it is a new edge. Correct, right? 0 to 1, 0 to 2, 1 to 0 already there. 1 to 2 is not there. 1 to 3, it is there. So 1 to 4, it is there. Yes, next coming to 2, 2 to 0 already there. 2 to 3, new edge. So then coming to 3, 3 to 1 already there. 3 to 2 already there. 3 to 4, yes, there is an edge. That's all. So these are nothing but 3, 4, 5, 6 edges which we have. Sir, now we have to implement a program to get these two values. Anyway, we will write code for this. Sir, we have to use BFS, beyond, sorry, DFS, beyond that nothing. Depth first search. We have to keep on moving to this depth. So is there any connection between this or not? We have to check. Anyway, I will show you how it is going to work. Can you please confirm, is this concept is clear for you people? Is this concept is clear for you people? Diagrammatic representation, please confirm. Sir, I request everyone to please respond because only few responses are coming. Right. Now, sir, we have some Boolean visited is there. So which is having an array like this, where each and every element is by default assigned with false. By default assigned with false. Now my requirement is for the node 0, which are adjacent nodes 1 and then 2. For node 1, which are adjacent, so 0 is adjacent, 0 is adjacent, next 3 is adjacent, 4 is adjacent. Sir, for node 2, which are adjacent 0 and 3. For node 3, which are adjacent, sir, 1 and then 2 and then 4. Sir, for the node 4, which are adjacent, so 1 and then 3. Sir, for node 5, which are adjacent, there is no adjacent. Okay. Now we have to determine. Sir, what I am going to do is, first step, I will create this Boolean array. So with how many vertices are there here? 4, 5. So 5 or 6, 6. So with all vertices, I created one Boolean array. So all these values are visited or not? Yes, visited. Okay. Now my requirement is nothing but we have to traverse one by one. Sir, this case I am explaining 0, 4. So here, what is the source? Source is nothing but 0. Destination is nothing but 4. Now my requirement is, my requirement is, sir, I am going to call DFS function. Okay. In that DFS, first it will take current node. What is the current node? 0. Sir, is this 0th node? We will mark it as visited. Yes, one second. Maybe I will use this for future purpose. Okay. Sir, now this 0 node is nothing but visited. True. Next, we will find out the list of adjacent nodes for this one, which are adjacent for 1, 1 and then 2. Right? We have 1 and then 2. Now, sir, first I will take 1. 1. Sir, is this 1 is visited? No, it is not visited. Then try to visit this one. Next, I am moving to this one. Try to visit this one. Sir, for 1, what it is going to take? 1 is visited. Okay, fine. It is visited. Sir, next what will happen? We are going to find out what are the adjacent nodes are there for 1. It is nothing but 0, 3 and then 4. Sir, is this 0 is visited? 0 vertex is visited? Yes. Is the third vertex is visited? No, it is not visited. So what will happen? It will transfer the control to third vertex. Sir, now third vertex, third vertex is nothing but visited. Now, what are the adjacent nodes for 3? It is nothing but we have 1 and then 2 and then 4. Like this we have. In this 1 completed, in this 0 completed. So 3 also completed. Sir, 1, 2, 4. Now, sir, destination 1. Sir, is it visited? Yes, it is already visited. Sir, next 2. Is it visited? No, not visited. Make it as a visited and call this 2. Next, what are the adjacent nodes for 2? We have 0 and then 3. So 0 and then 3. Sir, is the 0 is visited? Yes. Sir, is the 3 is visited? Yes. Backtrack. Backtrack. For 3, which are pending? 2. Sir, is the 2 is visited? Yes. Is the 4 is visited? No. Make 4 as a visited. Now find out adjacent nodes for 4, which are nothing but 1 and then 3. 1 and then 3. Is 1 is visited? Yes. Is 3 is visited? Yes. Now from 1, 1 second. From 3, we move to 4. Okay, we move to 4. This 4 got completed. Sir, any adjacent nodes is there? No. Sir, we have to come back. Again, here 4 is visited. Again, we here 4 is visited. Okay, again 4 is visited. Sir, now again come back. Now we have 2 is there. Sir, is 2 is visited? Yes. So already this has been completed. That's all, sir. Sir, now what output we are going to get? We have to return the destination value of this boolean. That is, in this boolean of 4, what is the value? True, right? Means what? There is a path. There is a path. But same case, if you take a b of 5, destination as a 5, sir, is there any path? No. Sir, is that node is visited or not? We are checking. Beyond that, nothing, sir. Okay. Can you please confirm? Yeah, we can do that, but every node we have to visit, right? Maybe I will check it. Sir, can you please confirm? Is the concept is clear for you people? If current node dot destination is equal to destination means we have to return true. Maybe it will work for every node or not. You need to cross check, sir, Vishal, sir. Okay, I will do that. Sir, clear up to this? Now we will see implementation of this program, sir. Okay, we will see implementation of this program. Let us see how it will be. We have graph is there. So directed, undirected edges are there. BFS, DFS, let it be. Now I'm going to take that same graph, which contains how many vertices? 6 vertices. And we have to add all the vertices. What about the links? 0 to 1, 0 to 2, 0 to 1, so 0 to 2. What about next one? 1 to 3, 1 to 4. So 1 to 3 and then 1 to 4. So next we have 2 to 3 is there. So 2 to 3 is there. So next G dot add undirected edge of we have from 3 to 4. Like this we have. Sir, first we will print the graph, then we will implement. Okay. So Java C, I am taking test.java, Java space a test. Sir, vertex 0 is connected to 1 and 2. Vertex 0 is connected to 1 and 2. So then next and after that, so vertex 1 is connected to 0, 3, 4. Vertex 1 is connected to 0, 3, 4. Yes. Next, vertex 2 is connected to 0 and 3. Vertex 2 is connected to 0 and 3. Vertex 3 is connected to 1 to 4. Vertex 3 is connected to 1 to 4. Okay. So vertex 4 is connected to 1 and 3. Vertex 4 is connected to 1 and 3. Vertex 5 is connected to nothing. Yes, perfect. Now we have to implement the code. Sir, what is that code here? So I am taking static, return type is Boolean. Okay. So has path. I will take a graph G and then source node and then destination. Like this I am taking. Okay. So integer number of vertices, I think no need because we know directly we will write. I'm creating a Boolean array. So with name visited of is equal to, so new Boolean of graph.v. How many vertices are there? With that length, I'm creating a Boolean array. Now I will call DFS utility functionality. Okay, utility functionality. So I will pass a graph and then that source vertex. From that we have to visit and then visited node I am going to send. Like this we have to do. Then at last I will return in that visited array. You have to take the destination. Is that value is true or not? It will print. But anyway, we have to implement that DFS util, right? Let us do that. So public Boolean, is it Boolean? No, void. So static void. So DFS util, which will take a graph G and then integer, sir, current node, current edge, I mean current vertex, and then Boolean visited. Boolean visited. This array I am going to take. Sir, now you have to decide. You have to trace everything. Sir, how to trace? As usual, you know, right? That visited of your current vertex will become true. Then you have to identify what are the adjacent nodes for that. So it is in the form of edge, right? It is in the form of edge. So temp is equal to So graph dot adjacency list dot get of, I am taking that current node. So it will display all the lists. Now what we have to do, for each edge value in this temp, one by one edge we have to check, and you need to cross check whether visited of e dot destination is equal to false. If it is not visited, try to make a call. So DFS util of, we have to pass that graph, and then e dot destination we have to pass, and then that visited array. That's all. So now it will do all this investigation, and finally it is going to have the visited array. In that, whatever destination you are trying to search, if that destination value is true, means there is a path. If that destination value is having false, means there is no path. Like that it will decide. Now I'm going to print system dot out dot println of, so graph dot, so has a path of, in this graph, is there any path from 0 to 4? My expected output is nothing but true. Similarly, system dot out dot println, so in this graph, is there any path from sir G to 0 comma 5? There is no path, right? In such cases it will return false. But let me check whether really we are getting this output or not. You can see there is a path from 0 to 4, and there is no path from 0 to 5. Like this we have. Okay. So I think you people got clear clarity about how this has path method is going to work. Can you please confirm everyone is the concept is clear? I request everyone to please respond. Clear up to this? Please confirm. Everyone, please respond, sir. Right. So next one. 1 second, please wait. Yes. Yeah. Swapnil, we will see if there is a possibility, definitely. Next, sir, the next application, of course, related to this DFS and BFS only. Sir, we have to count all paths. We have to count all paths from source to destination. Okay, from source to destination, what are the possible paths are there? We have to count that. We have to count that paths. Okay. Sir, here we have given a source and a source and destination vertices. Okay. Sir, what is your task? So here task is nothing, but we have to count of all paths from source to destination. Source to destination, what are the possible paths are there? We have to find out. Okay, we have to find out. I think if you take this example, otherwise I will go with one more example. Okay, so consider this is nothing but 0th node, and this is nothing but my first node, second node, third node, and then fourth node. Like this we have, and assume the connections are like this. Like this. So here this node will become 0, and this node will become 1, and this node will become 2, this node will become 3, and this node will become 4. Sir, for this graph, we have to identify, so how many paths are there? Okay, assume I want to call count paths. Okay, I want to count paths, count all paths. So from in this graph, from 0 to 4, how many paths are there? We have to find out. Sir, meanwhile, can you please give me the answer? How many paths will be there? So meanwhile, I will write that representations. Can you please count and then tell me? From 0, we have 1 is there. From 0, we have 2 is there. So from 1, we have 0 is there. Okay, no need to write. And from 1, we have 3 is there. And from 1, we have 4 is there. And from 2, we have 0 is there. Already it is there. From 2, we have 3 is there. Okay, that's all. And from 3, we have 1 is there. Already it is there. From 3 to 2, we have already it is there. So 3 to 4. That's all. From 4 to 1, it is already there. From 4 to 3, it is already there. Yeah. Can you please confirm how many paths are there? 10 paths. Ayyo. Okay, we will do one thing. We will check. Sir, with the different colors I am identifying. So this is one path. Plus this is another path. Plus this is one path. Plus any other possibility? Can I take like this? This is another path. So from here to here, from here to here, from here to here, from here to here. That's all right. I think 4 possibilities are there, correct? Yes, 4 possibilities are there. Sir, for this we have to implement the program, sir. Let us see how it will be. Okay. So the output what we are going to get here is nothing but 4. The output is nothing but 4. Okay, let us see how we are going to get. Sir, now what is our requirement here? As usual, we have to maintain a visited array. Okay, Boolean array to hold how many values? 0, 1, 2, 3, 4. Okay, up to this we have to maintain. Now I'm going to represent the paths as this one is 0th vertex, first vertex, second vertex, so third vertex, and then fourth vertex. By default, all these values are nothing but what, sir? False. By default, all these values are nothing but false. Now we have to call which method? Count all paths method. So by passing this graph, and then 0 is nothing but a source vertex. Okay, then we have to pass a destination. Now we will see how it is going to work. Suppose if a source and destination are same, there is only one path. If a source and destination are same, then there is only one path. Now initialize count is equal to 0. Initialize count is equal to 0. Then first we have to find out what are the adjacent nodes for 1. What are the adjacent nodes for 1? So make this 0, since it is a source, right? Make this 0 as a visited. Now we have to find out adjacent nodes. Which are adjacent nodes for this? I think we are going to get 1 and then 2. Okay, 1 and then 2. Next, what we have to do? Take 1 and check whether is it visited or not. Sir, is it visited? No, it is not visited. If it is not visited, there is a edge, right? There is an edge. Then, so what we have to do? You need to maintain count by 1 unit. Count by 1 unit. Okay, count by 1 unit. Sir, next and after that, we have to call this particular count by 1 unit or 1 second. Don't count by 1 unit. We have to call this. So 0 to 1, again we have to make recursive call. Now what will happen? it is going to move to this and it is going to check. Sir, 1 is this, 1 will become now source vertex. This 1 will become now source vertex. Sir, now please cross check, is it visited or not visited? It is not visited. So make it as a visited and find out. So what are the adjacent nodes for this one? For one which are adjacent, sir, we have 0 and we have 3 and then we have 4. 3 nodes are there. Okay, 3 nodes are there. Now what will happen? We have to select the first one, that is nothing but 0. We have to select the first one. Sir, is the node is visited or not? Yes, node is visited. Okay, when we are sending this 0, I think your source and destination are same. One second. No, it is not the same. Source and destination are not the same. Hmm. Sir, 1 second, please wait. One more time I am traversing, sir. Please listen carefully. First, we will start from source vertex. We will start from source vertex. That is nothing but 0. So we have to check, we have to make this source as visited. That is nothing but true. Next, we will find out what are the adjacent nodes for this 0, which are adjacent 1 and then 2. Okay. Sir, is 1 is visited? No. If a 1 is not visited, so we can move into this direction. Okay, we can move into this direction. Then what will happen? Again, I am going to apply the same process. Again, I am going to apply the same call. Now your source will become 1. Destination is 4 only. Destination is 4 only. Now what will happen? 1 will become source, 4 is nothing but a destination. Is these two are same? No. Until these two become same, we have to repeat. Previously it was 0 4, now it is 1 4. Sir, is source and destination are same? No. Then what will happen? Visited of this 1 will become true, and we have to identify which nodes are adjacent for this. Which are adjacent for 1? So for 1 we have 0 is there, so 3 is there, 4 is there. Now check whether 0 is visited. Yes, it is visited. If it is visited, no need to go. If it is not visited, we have to continue. So it is not there. Then, sir, 3, is it visited? No, not visited, right? So then what we have to do? So we have to go to from 1 to 3. Okay, we have to go to from 1 to 3. Sir, now I am making 3 as a visited. So what are the adjacent nodes for 3? We have 1 is there, 2 is there, 4 is there. Is 1 is visited? Yes, it is already visited. Is 2 is visited? Yes, 2 is not visited. So then make 2 as a visited. Again, we have to go here. Sir, again it will come back here. It is already visited. So backtrack. Again backtrack. So next node will become like this. Okay. So next node, maybe after completion of this 2, for 4, you are going to get like this. Now, in this case, already we have verified 3, 4, and we have verified 4, 4. Whenever we are getting 4, 4, then this function is going to return 1. So this function is going to return 1. That means, so from which direction to which direction we moved? Sir, if you observe carefully, second, if you observe carefully, from here we came here, and from here we came here. Okay, this is one path. Then while coming to the backtracking, sir, whatever latest visited that you have done, make it as unvisited. And one step backward. Sir, make it as unvisited. One step backward. For one which are visited, already we completed this 3, right? What is the next path? 4. In this, source and destination are same, right? So it will be incremented by 1 unit. Again come back. Now it will move to this one, and from here it will move. From here it will move. So it will become 1. Now completed, right? Backtrack. Sir, now from here it will, and from here we will come here. So one more step. Like that it is going to do. Sir, here we are using recursion. At the same time, we are using backtracking. Sir, don't worry. In the code, you will get clarity. But overall concept, is it clear for you people, friends? Please confirm everyone. Is the concept is clear? Right. Crystal is very clear. Very good. Now see how I am going to write the program for this. Sir, it's a very simple, sir. This has a path and this function I am removing. Now observe carefully. Sir, I am going to write static integer function. So count all paths. Count all paths. Okay. Count all paths. Here we have to take a graph G and then we have to pass source vertex and then we have to pass destination vertex. So here I'm going to create a Boolean array with name visited is equal to, so new Boolean array with graph dot vertices. Then what we have to do, I'm going to return count all paths function by passing graph comma that visited array also we have to pass visited array and then as usual, I'm passing my source and then destination. That's all. Sir, we have to write one more function called integer count all paths where it will receive a graph G and then a Boolean visited array and then integer source and then destination. Integer destination. With these values, sorry, with these values, I'm going to create a function. Sir, what this function is going to do? Since it is a recursion, I'm writing the base condition. If your source is equal to destination, it will return 1. Till that it will move. Okay. Sir, I will write recursion logic here. I will write recursion logic here. But I need backtracking logic also, right? Because we have to move one step forward. So that is nothing but visited of your source will become false. Then we have to return at last count value. Sir, what is the count? Initially, my count is equal to 0. And then we have to make this visited of your source will become true to start the recursion. So from this place, it will keep on moving to the destination. Once if it is reached to destination, it will give your result as 1. And one step backward while coming, it will assign these source values as a false so that there is a possibility to move to the next path. There is a possibility to move to the next path. Like that it will take. Okay. Now what we are doing here, we know very well. We have to create a linked list with some edge. So temp is equal to, so graph dot adjacency list dot, so get of current node. Okay. Here, what is the current value? I think source is nothing but our current value. Okay. Yeah, 0 is not required. Definitely, if there is a path, it will move up to that. If there is no path, it will terminate in the recursion itself. Okay. Right. So now we have to write for each loop, for each edge present in this temp. One by one edge value we have to print. So if visited of e dot destination is equal to false, that means if the node is not visited, then you have a path, right? So you can go by taking visited array and e dot destination, that is next adjacent node, and then destination is same. Like this, it will keep on, sir. That's all. Now we will see really is there any path or not. Okay, like this I am going to check. So here we will take a graph with 5 elements. Okay, with 5 elements. So first node is nothing but 0 to 1 is this is, yeah, 0 to 1, 0 to 2. 0 to 1, 0 to 2. Next and after that 1 to 3, 1 to 4, 1 to 3, 1 to 4. Next and after that 2 to 3, 2 to 3, 3 to 4. Yes, the same graph is there. So we have to call, so count So count all paths from in this graph from 0 to 4. From 0 to 4. This is my requirement. So how many paths we are expecting? 4 paths. Let me check. Is it going to print all these 4 paths are? Sir, is all these 4 paths are available or? Yes. But I have one more doubt. Let us take any other vertices and we will check how many paths are there. So you have to give response from for this. Okay. Can you please confirm? So to move from 1 to 2, how many paths are there? Can you please confirm? To move from 0 to 2, how many paths will be there? Don't tell one. Don't tell one. Don't tell one. Is it the only one path? So this is one path. So like this we can go. This is another path. Okay. Like this we can go. This is another path. Okay. Next, like this we can go. This is another path. Okay. Next, any other? Maybe that's all. 1, 2, 3. Here also 4. Let me check. 0 to 2. 0 to 2. How many paths will be there? We will see. Yeah, 3 paths. How it is 3? Sir, from here it is 1. 1 second. From here it is 1. And it will move like this. This is nothing but a 2. Then from here to here it is 3. From 0 to 1, 1 to 4, 4 to 3. Like this, there is no chance. Okay, maybe 3. Okay. Yeah, yeah. So like this we have. Okay. I think you people got very clear clarity how you can able to count all paths from the given source to destination. Can you please confirm, friends? Clear up to this? Clear up to this? I request everyone to please respond. Sir, how to find the shortest or longest path? We will discuss. Don't worry. We will see that. We have some algorithms are there. We will look into that. Okay, don't worry. Now, sir, can you please print? Can you please print all paths from source to destination? Okay, I want to print all paths from source to destination. Sir, program is the same. No change at all. No change at all. But we need to capture the paths. We need to capture the paths. That's all. Nothing, sir. Everything is the same. Sir, now I'm going to take like this. Sir, print all paths. Okay, print all paths. Print all paths from 0 to 4. That's all. It will print all the paths. Sir, what we have to do? I will change this function name. Print all paths. It is going to take return type as a void. Okay. And it will take a graph source and then vertex. So, sorry, destination. I'm creating visited at the same time. Sir, I will create a stack. I will create a stack. Stack to hold integer objects. My stack is going to hold integer objects. Stack integer. 1 second. Right. So here I'm going to take a stack integer s is equal to. Otherwise, let us take a path is equal to. So new stack I'm taking. Okay. So new stack I'm taking, which is going to hold integer objects, just empty bracket. That's all. So while calling this print all paths function, I'm not going to return. Simply, I will call print all paths. In addition to this graph and visited array, source, destination, I will pass path also. Okay. But while receiving here, okay, while receiving here, it is going to take another attribute. What is that attribute? It will take a stack which is holding integer objects. That stack name is nothing but path. Sir, what this path is going to do? Listen my words carefully. Some small changes. At very beginning, in the path, I am trying to push a source, sir. Initially, whatever source is there, that will be pushed into the stack. If your source and destination both are same, that means what? There is a path. In such cases, can you please print that path? Can you please print that path? Because it is the base condition. Then after that, can you please pop one item? Last item, it will be popped. That means one step backward. It is also a backtracking. Then we have to return empty. That's all. So one item is going to be popped. Up to that, it will print. Next, it will continue for the rest of the things. Now here, we are not counting. Make it as remove. Visited of source will become true, and we have to take this as it is. Then if there is a edge, then visited of that edge is equal to false, means we have to call this same function. Okay, we have to call this same function by passing this graph and then visited and then e dot destination. Okay, e dot destination and then path. Like this we have to take. Then after that, visited of source will become path, and at last we have to remove if there is a no path. One step backward here itself we are doing. So once if there is a path, we have to print that, and the last node we have to remove. So like here you can able to see, if there is a successful path is there, we have to remove this force and we have to continue from 1. Suppose I came to 0 to 1 and 0 to 3. This 3 is already visited. From this one step backward, right? That means if a path is not reached to the destination, then also we have to perform one pop operation. That pop operation is nothing but here at the last. Okay, in the backtracking. Now, sir, we have to check whether is this stack contains a proper list or not, because every time at the very beginning it will try to push. If there is no path, then it will pop. Like this it is going to do. Now I think everything is clear, but let me check really is it working or not. Somewhere print all paths. Any spelling mistakes? Graph 0 comma graph 0 comma source comma 0 comma 1 second. Here graph visited destination and then we have to pass that path also. Now let's compile. Perfect. Let's run. Sir, are you seeing here 4 paths are there? Have you observed how it is moving from 1 to 1, 0 to 1? So 1 to 3, so 3 to 4. After completion of this, it will remove 4. So 0 to 1 will be there. So 1 to 3 will be there. Sir, it will remove this. And 0 to 1, is there any path from 1 to 4 directly? Yes, it will print. Then again it will be removed 0 to 1. Is there any continuation? No. Then from 0 to 2, it will start again investigating. Like that we are going to get. This is nothing but the path from 0 to 4. Now, I think one more path we have seen, right? 0 to 2, we got 3 paths. Let me check that one. 0 to 2. Is there 3 paths? Yes, 0, 1, 0, 1, 3, 2, 0, 1, 4, 3, 2, 0, 2. Okay, have you observed in the diagram? So we have 0, 0 to 2, 0 to 2. So then 0, 1, 4, 3, 2, 0, 1, 4, 3, 2. Then 0, 1, 3, 2, 0, 1, 3, 2. Like this we have. Okay. This is nothing but how you can able to print all paths from source to destination. Can you please confirm, friends? Is this concept is clear for you people? I request everyone to please respond. Clear up to this? Please confirm. Clear up to this? Right. So remaining things we will continue tomorrow. Sir, tomorrow we are going to talk about how to detect the cycles in directed graph, undirected graph, how to find out the cycles. So next and after that, transpose of the given graph, like some of the applications are there, that part we will discuss. Okay. Yeah, spanning tree, minimum cost spanning tree, these things we will decide. Okay. Right, sir. So thank you. We will meet for the continuation tomorrow. I will upload the running notes within a few minutes. Thank you, guys.